And we are recording. So what's going on, everybody? So we're going to do a slightly different episode of Richard on Data today. I'm joined today by none other than, I'm going to attempt not to butcher the pronunciation of the name, Chanin Nantasenamat, also known as the Data Professor. So we're coming together today to talk a lot about some of the differences between academic data science and what you may do in industry. And luckily, Chanin comes to us here with, I think, 15 plus years of experience in academic data science, just with data science in general. So I hope you guys will appreciate his perspective today. So Chanin, thanks for coming on board of my channel today. I would imagine there's an enormous amount of overlap in, your audience and my audience. But for those who follow me but haven't seen your channel or heard of your channel, could you start off just telling us all about your background and just what you've done thus far in data science, to the extent it's been involved in academia as well as in industry as well?
Okay, sure. Yeah, so first off, thanks, Richard, for having me here for this awesome discussion. So a little bit about my background. So I have a bachelor's in biology, so quite non-technical, and I have came across data science during the course of my PhD studies. And it was about in my second year that I was acquainted with a newly graduate PhD graduate from the US. So he just got his PhD in data mining. And then we met, and then he gave me this book, Artificial Neural Network for Drug Discovery. And then we had an initial discussion. And then other than that, he was quite busy. So then I kind of self-taught myself data mining. And the first program that I was using was called Weka. It's a Java-based graphical user interface for doing data mining. So you could essentially click some buttons to import data, click some buttons to pre-process the data. And I used a lot of Excel and a lot of text editors. So my start was not starting from a programming background. So mine was more like a, so to say, like a data analyst. So you're probably using like packages, ready to use software like SPSS, Microsoft Excel. And so my start in doing coding was toward the end of my PhD studies, where I started to dabble in C++, Java, and then finally into Python. And a little bit before Python, it was MATLAB. And then from Python, I hopped into R. I fell in love with Shiny package, so awesome. And then I moved back to Python for this YouTube channel. And also for some of the data science projects that we do for our research. And my YouTube journey started last year. And so in a nutshell, my daughter suggested that I should start a YouTube channel. And then I took some time to overcome the procrastination, overcome the imposter syndrome, and then finally hit the record button. And then 1 year later, and here I am today. And I find this journey an awesome journey, get to meet a lot of like-minded individuals, awesome people like yourself, Richard, and it's awesome to be here.
Yeah, I was going to poke you about telling the story about how you got into YouTube, because I knew that story, but I wanted my audience to hear it because that's really an awesome story. I'm right there with you. Like personally, I did the same thing with overcoming imposter syndrome and getting into data science to a certain extent, but certainly into YouTube. And it's something that I wish I'd done significantly earlier than I did, because I learned tons as I've done it myself. Could you talk about how you actually landed your first job getting paid to do data science?
Right. So straight out of so I did my PhD right after graduating from bachelor's. And so actually, technically, I did not graduate my bachelor's. I approached a potential PhD advisor, and then he accepted me into his lab. And then I kind of started to do some research in the lab, and also started to audit some courses before graduating my bachelor's degree. And because at the final year in the final semester, I had like about 2 courses left. And so I was pretty free. And so I kind of joined early into the PhD program, auditing some courses and getting a head start, learning about what's research all about. And so by the time I graduated, I could immediately start doing some preliminary research and also to finalize the coursework. And then, yeah, so after that, it becomes pretty amazing to discover data science through biological data. And I wouldn't know what would happen if I didn't come into this field of biology. Would I stumble upon data science? So it didn't really happen that I really liked data science from the get-go. So it just kind of came to me as a biologist, having to analyze big data, having to struggle with analyzing big data. And so, I mean, data science seems to be the natural problem solver. And then when I was acquainted with data science, I mean, it's never been the same again. So it's an awesome field to work in.
What do you think has been the bigger passion for you? Do you think it's biology or do you think it's data science?
Okay. That's a tough question. Let's see. I would say at the interface. So if purely biology, I'm a bit bored into the mechanism. So I've also experimented. I've done some wet lab experiments, did some gene cloning, engineered some proteins, synthesized some compounds. So like at the interface of biology, chemistry, and also informatics. But what I really liked are the data that are coming from biology and coming from chemistry. And so it's analyzing those biology data, chemistry data is what fascinates me. Yeah. And the thing with all of these biological research and chemical research is that they have research labs have spent a lot of money collecting data, and they might not have analyzed the data to its full potential. So for example, if we think of it like a cup, they might have analyzed it from only this viewpoint, but then the other 360-degree viewpoint is still unanalyzed. And also in statistics, there's this meta-analysis where you just pull results from several hundred research papers in order to up its statistical significance. And so I believe that there's huge potential for data science in biology. And so dissecting it as one or the other is quite difficult. And I believe that all biologists, or essentially all scientists, are essentially data scientists, because scientists, they perform experiments to generate data, and then they have to analyze the data. And typically, the data that they analyze, they might use traditional statistical approach, they might use traditional data visualization, but then there's huge potential if they could expand their domain into machine learning, into statistical visualization. I mean, there's a lot to be done there.
Yeah, you don't know what you don't know. And I mean, unless somebody is around you who puts that idea into your brain, somebody who has some kind of, I don't want to even say expertise with, but at least awareness of what kind of problems can be solved with those techniques. Unless somebody like that is around, you're never, I'm sure, in that field going to realize your full potential.
Exactly.
How big of data sets do you typically work with in that domain?
Yeah, so the common data set. So let's see, the common data source that I'm typically working with is derived from biological and chemical databases. Yeah. So the big chunk of my research is on drug discovery, computational drug discovery. So chemical libraries are in the millions. And so But then the biological activity, they're quite limited to a couple of thousand or 10,000 data points. So my data is not so big, and so we could typically build a model out of 1,000 to 10,000 compounds. And then the big data part will come from deploying the model and then screening an entire chemical library of a couple millions by applying the predictive model that we have created. Yeah.
Yeah, very interesting. Most of the time, how clean is the data that you get? Is it typically ready to go? You're ready to explore it, spin visualizations up, do machine learning models. I mean, the joke in industry data science is you spend 80% of your time cleaning data and you spend the other 20% of the time complaining about cleaning data. So in academia, I'm more curious, what does that breakdown look like? Is data more clean, less clean?
Yeah, that's a great question. And so predominantly they're unclean. And so the thing is, it really depends on the data set that you're taking it from. If you're taking it from a published paper and then you're just reproducing their work by applying a new algorithm, so you're using essentially their data set that they have already cleaned, so that is ready to be used. But then if you want to create your own original data set, which will be more appealing to the reviewers, the peer reviewers who will be evaluating the research findings. So if you collect your own data set, then that requires a lot of like figuring out like what kind of data do you want to compile, from where, and let's say that you're compiling data from different data sources, so they're very heterogeneous. And so you have to make them in a similar format. You might take a subset of one data set from another data set and then you combine them, and then you have to clean them. You have to find a way to make it more homogeneous. And so that requires a lot of pre-processing. And so most of the biological data set that I have, we also have to do some form of feature engineering, doing some log transformation in order to make the distribution more normally distributed. And then, I mean, a typical data cleaning, I mean, if we're not using coding before, it would have taken me half a year for one project. And after using Python, it greatly reduced that time. And I mean, not only Python, but also R. So imagine from half a year to 10 seconds. So we created our own in-house scripts in R, and then we created a web server. So a web server is like just a typical web application. So the user can just upload the data set and click on the submit button.
Yeah.
And then within a couple of seconds, it will pre-process, it will clean, it will curate the data set. And so what used to take half a year is now in a couple of seconds. And so we're planning to publish this work very soon. And it greatly enhances, it really augments our data pipeline. And it makes our life a lot easier now.
See, it's really interesting you say that, because there's a lot of people out there who kind of freak out about AutoML and all these new automatic data cleaning technologies, and how as those things come to more prominence and they gain maturity, that's going to come at the expense of certain people's jobs, right? Because like you said, I mean, if all that work takes a year, then humans don't necessarily have to do it anymore. But you're kind of standing on the shoulders of giants there, right? Because you don't have to waste as much time doing that kind of stuff. You could do cooler, more inventive, more interesting things, right?
Exactly. So instead of spending time on the grunt work of cleaning the data, you could spend more time in reading more papers, learning more algorithms, trying out new workflows. And so it's not that AutoML or automated data pipelining will replace data scientists. It's essentially, it will shift our focus from a more manual or grunt work into more creative, more advanced. I mean, or even provide us more time to learn new tools.
Oh yeah, I couldn't agree more. So a lot of this is somewhat high level, certainly with respect to projects. Is it possible to describe more of the day-to-day of your life as a data scientist?
Yeah, so day to day, so by daytime, I'm a associate professor at a research university in Thailand. And so my typical day will involve either teaching, doing research, talking to members in the research lab, supervising undergraduates or graduate students, being in meetings, and also work at it as an administrator because currently I'm one of the head of the Center of Data Mining, and also another is I try to block time to learn new techniques, new algorithms in order to add novelty to research project. And as a process, I'm trying to make this YouTuber thing, which is like a part-time job that
Yeah.
I do in the evening and also on the weekend. And so how do I manage both at the same time? So I try to make that if I'm learning new algorithms, if I'm learning new tools or techniques, then I try to make a video about that. And the tutorial video will be uploaded to my YouTube channel. And at the same time, I'll be learning a new tool, which I could use in my daytime job in the research project. So kind of like a win-win situation.
That is a complete best of both worlds. Like I'm right there with you. Like the more I do videos, the more I like pick up on little nuances, or I realize that maybe some function has been updated, and they're just these. It all comes down to these little things that I learn every single time that I make a video. So it's certainly educational on my end. And I was going to ask you about that actually, with just the ability to learn new technologies, because I think in industry, a lot of the time, everybody has a huge desire to learn new technologies, new programming languages, just things like that, just because the pressure across the data science market as a whole, the pressure to know a large number of things is quite great. And it varies a lot, I think, in industry for how much you're actually able to learn inside of your particular job, because you're not there to learn, you're there to provide value, you're there to contribute to a project. So I was really curious how much time and to what extent you're able to spend learning technologies.
Yeah, so one of the core component of being a researcher is to introduce novelty in every research project that we're doing. Because the thing is, if we send our work for publication, the peer reviewers will look at what is the novelty of our research. Are we providing, what kind of new value, what values are we providing? Are we using a new data set? Are we providing new insight into how disease are happening? Are we introducing a new bioinformatic tools? Are we introducing a new machine learning algorithm or a tweak to an existing algorithm? Or what other improvements are we making to the fields and that would be appealing to the audiences or the readers of the research papers? And so all of this is kind of like an incentive and also a pressure at the same time that keeps me motivated to also learn new algorithms and tools in order to be relevant in publishing. Yeah.
Yeah, I mean, that's not far off. Like the best opportunities I've had in industry style work to learn a new technique, language, whatever it is, it's because we really needed to be innovative in some way, shape, or form. We couldn't do just something that's been done over and over again. It had to be something that's really new and creative. So that's really interesting. That's similar. Yeah, you know, there's a Medium article on that talks about going from academia to industry and data science, and it made a point which is pretty interesting to me. Like it made a comparison saying people in industry, they tend to work on a problem for a few months, and then they get to where it's good enough, then they move on to something else, which I find that to be generally true. Like you have to a certain extent, you ask yourself, what is this, a 2-week problem, a 2-month problem, a 2-year problem? And rarely are you going to work on something for 2 years. Now, the description they gave of academic data science said that you're basically spending months or even years on a particular problem, making your solution better and better and better and optimizing it. Now, that's what the Medium article said. Do you agree or disagree with that?
Yeah. I'm not sure, maybe that's in another situation, but for my own situation, I think it's much similar to industry that you were mentioning about. So most of the projects that we're doing is more student or researcher centric. So members of my research lab, each member would be working on their own projects, and then I would be involved in helping to analyze the results or maybe providing some suggestion. And so each of the members will have their own projects. And so, yeah, they will be responsible for, like creating, planning, envisioning what kind of direction that they want to go through. And each project would typically take about no more than 4 to 6 months in order to be competitive, because if it's longer, then someone else around the world, I mean, it could be anyone, will publish something similar to what we're doing, and then that will render our project pretty much irrelevant.
Yeah.
And we see that a lot. And so it's kind of like a race against time to publish it, to be the first to publish that, that niche area that we wanted to explore. Yeah. So it's not that we're in a very long-term project, like spending 2 years optimizing a method. I mean,
sure.
Pretty much we're working on this Pareto principle, and I'm sure Kenji and you're also working on that as well. Yes. So we try to spend minimal time, like maybe 20% of our effort to get as much, like 80% of the project to be finished. And then we'll polish it off to a certain degree that is, it's workable and it has solved the issue and it's ready to be published. I mean, all of the major potential roadblocks are solved. But most of the projects that are refining the remainder 20%, I mean, that might take a couple of years to make it perfect. I mean, I don't think any project could be perfect. No. Because solutions can come, like in many ways. It's kind of like coding. You could solve the same problem using hundreds of possible solutions. So I guess we're trying to be as efficient as possible, and we're trying to weight the cost to the time and the cost it takes to complete the project. So not too long, not too short. So we're trying to find a sweet spot for that. And normally no more than half a year on a single project.
Yeah, that makes a lot of sense. Yeah, I mean, yeah, based on what you described, I don't think that's too different. I mean, like from how industry is, like what you said, a Pareto principle sort of thing. Yeah, I mean, I can totally relate to that. Now, the other thing is, do you think, or has it been your experience, it's not necessarily as important to have the best written code necessarily, like best coding practices aren't necessarily the most important thing. Having the most readable code, having the most efficient code, that kind of thing kind of takes a back seat to other priorities. Has that been your experience?
Yeah, so I agree, I totally agree. So as long as the code is getting what it's meant to be doing, then it's fine with me. But if we're dealing with larger data set where timing is critical, then maybe we might need to optimize that. So our approach is to get a minimal viable code to be functioning. And if it's functioning and it's working as it's intended to be working, then we just leave it as is, and then we move on to the next problem, and then we try to solve that. And then, however, if we're scaling up the project, and then if time is an issue, then we have to figure out how can we make it faster. Should we use GPU computing? Should we use parallel computing? So we're trying to solve problems as they come. And if it's working, I mean, but most importantly, it should be very well documented, at least commented, like this block of code is doing this, this block of code is doing this, so that in the future we could pretty much make use of it like a Lego building block. So if it's modular, we could reuse some of the components in the future project. Yeah, so documentation and making it work. And if there's no problem, use it. And if there's a problem that we need to deal with, then we just solve it as it comes along.
Okay. Yeah. Oh, awesome. All right. So yeah, I'm curious for somebody who's maybe they're an undergrad, maybe they're starting a master's, maybe they're very early on in a PhD. I personally know several people who got a year or two into a PhD program and then they dropped out. They decided that that wasn't right for them. So somebody at that level, how do you think they should best decide what is the best pathway for them? Should they do a more academic route in data science? Like suppose they've heard about data science, they're super interested in that, but the question is, do you do it in more of an academic capacity or do you move to industry? Do you have any tips for how you kind of make that personal decision?
Right. So, so back at the time, there were no standardized pathway to get into data science. So my pathway into data science was kind of by luck. I kind of stumbled upon it, and then I kind of self-taught myself through solving small problems, each step at a time.
Mm-hmm.
And then by solving each step, each small problem, it kind of, I mean, all of the problem, if you take a high level view, bird's eye view, if you could categorize the problems, then I mean, they would fall into separate categories. Like, okay, learning this Python coding, handling the data set, pre-processing the data is like one cluster. Model building, how to make the model more efficient, more predictive is one. How to interpret the model, how to make sense of it, how to provide value to the data, how to allow biologists, chemist, or a non-technical person to understand the implications of the model.
Yeah.
And so all of these are pretty distinct. And I would say they're pretty modular. And so, and then for my own pathway, it's pretty much I stumbled upon it problem by problem and solving it one by one. And then I mean, it's pretty unstructured if you come to think of it.
Yeah.
And for those newcomers to the field, I would say it requires great passion and also discipline and also dedication and also frustration. Because, you know, like when you're debugging codes, when you're in a situation when you're encountering problems, so you're feeling uncomfortable. So I guess to become comfortable with the uncomfortable, and I mean, data science is not a clear path, but nowadays it's becoming more or less structured. So there are a lot of great resources for you to learn data science, like what DataCamp, 365 Data Science, Data Quest, and then most of the universities are having very good structured programs. And they even have a bachelor's of science degree in data science. And Jamin Lee from Import Data, he has also graduated data science bachelor's degree. And I mean, there's bachelor's, master's, and now PhD in data science and business analytics, even machine learning, applied data science. So the field is expanding, it's maturing, and it's getting a bit easier to get into data science because of the expanding resources that are available. So I would say for those who want to get into data science, there's ample opportunity, a lot of free resources out there, like Coursera, edX, for example. So pick one, as Richard, you have also said, for learning, pick up R or Python. So because when there's so many options, a common problem that you might encounter is you don't decide, because when there's too many options, you're pretty much having this decision fatigue. You're tired of, should I go with A, B, C? And then you're like, okay, I'm not gonna decide. So, but don't overthink it, choose one and then just move on to the next. And by stumbling upon the problem from the first option, you might figure that it works for you, or it might not work for you, and then you could decide again. So let the situation take you. So don't overthink it and just get a head start. Just start today if you want to get started in data science.
Yeah, I mean, just to piggyback off a few things you just said there, you're right. There's so many resources available now, and that there's so many that it can cause a decision fatigue, right? And that's why I
Mhm,
think you get a lot of people asking, what are the best books I should read? What are the best YouTube channels I should watch? What are the best
mm,
machine learning algorithms I should get really familiar with? And I mean, like you said, the path for data science is going to look somewhat different for every single person. I think we
mhm,
are getting a little bit more structured now, which is a very good thing because people don't necessarily thrive in super unstructured environments. Like people like some degree of order and balance and structure. So like the way
mhm,
I always try to put it together, like the way I try to think about it is when I recommend what people should learn is I try to kind of serve the highest percentage of people possible, right? And so we
mhm,
talked about this in the conversation that we did on your channel, but I've recommended that people start by number one, learning statistics, number two, learning SQL, number three, learning one of R or Python, because you're going to have to do those things or all those things in, I'd say, the majority of data science jobs out there. And it's about you get good at one thing, at least you have that strength going for you. Like personally, I don't know if you've seen the show Parks and Rec. You've heard of, or the character Ron Swanson. He says, "Don't half-ass a bunch of things, whole-ass one thing." That's totally my philosophy with data
mm.
science too. So I guess my final question for you would be, let's say to some of these people who get on the data science subreddit and they ask, I want to get into data science, but I have no math background, no statistics background, no nothing, no programming background, nothing. Where do I start? What do you say to that person?
Mm. Yeah. So actually, I made a video and I've written a Medium article called Strategies for Learning Data Science. So I would recommend similar to what you are suggesting as well. So obviously the first thing, and also I've drawn an infographic on the 8 skill sets to becoming a data scientist and also a video about that as well. So maybe I could also share that in one of your comments on your channel.
Yeah.
And so I mean, there's many paths. I mean, let's say that if there's 8 skill sets, which I have analyzed the entire LinkedIn, and then I clustered them into 8 skill sets. So one of them is data pre-processing, data munging, you could call it, data wrangling. And so that will require you to, compile your data, curate your data, clean the data, and make it higher quality, more structured, so to say. And another would be to embrace and pick up a programming language. And it could be R or Python, as you have already mentioned. And then be familiar with some of the major libraries or packages that will allow you to get through 80% of the data science projects. So obviously the first one would be to learn about pandas or data frame for R, pandas for Python. Pick up a machine learning library, like in R, it could be Carrot. In Python, it could be scikit-learn. And if you're into deploying your models in order to have stakeholders or customers to visualize the data or play around with the insights from the data, then you could learn and use Shiny for R, or you could also learn and pick up Streamlit for Python. And more advanced would be to learn Flask, to deploy web application or make an API of that. And so it's about learning the tools of the trade and using the libraries or packages that are giving you superpowers in data science, allowing you to do most of the tasks. And then once you work your way up there, then you could embrace with deep learning and other text pre-processing or text mining approaches, natural language processing, computer vision. So this really depends on which niche area of data science that you want to work with. And so this also depends on the type of data that you're working with. Will it be images? Will it be streaming data? Will it be like a typical, like a CSV file? Would it be a SQL database? So all of this is very, it's really dependent on the area that you're coming from, the company that you're wanting to work in. And yeah. And aside from that is to do data science. So at the end of every video, I would say best way to learn data science is do data science, because by solving projects, you'll know which are your weak points, and then you could embrace that, learn it, learn about various solutions that you could solve the same problem. And by doing more projects, you'll pick up more experience, and then you'll recognize at the get-go, like this problem needs this solution, this problem needs this solution. So if you solve 100 projects, aim for as much project to solve and work on as much as possible. And another is to share the completed project onto GitHub, and also make a portfolio website if you can. Talk about the project. You mentioned in the video that we have collaborated that when you're describing a project, you need to tell what is the significance of the data, what is the significance of the project, what approach did you use, what is the problem, how did you tackle it, what's the novelty, what's the value that we could get out of the project that you're working on. So if you could share all of these in the data science portfolio website, it would be very appealing to the employers. Yeah.
Yeah, awesome. All right, well, that's all the questions that I have for you. So yeah, Chanin, thanks so much for coming on my channel. Appreciate you having this conversation here with me. I learned a lot from you, and I'm sure my audience did as well. So thanks again, man.
Yeah, thank you so much, Richard.
Yeah, absolutely. So that about does it for this. So just
all right.
From you guys out there, as always, number one, Chanin's channel is Data Professor, so check that out and subscribe to it because it's awesome. Check out the interview that I've done on his channel. We did another collab where I talk about some of my experiences, so check that one out too. On both of those videos, smash the like button because that really helps our just channels reach a larger audience in general. Then I'll see you all in the not so distant future. Until then, Richard, on data.